Okay, as you watch this next video, I'm not really going to do a lot of talking, so you can even like put this on double or triple speed and just follow along. Pause when you see me do something, and then maybe like start for asking me for conversation when we come back to class later. Once again, the entry task is fabulous extra practice. If you need anything for review, then make sure you do those. Kind of consider the questions that are there because they're great questions. But I want to dive into the notes and the meat of what you need for this lesson. So as I move on, your sound's not broken. I'm just not going to do a lot of talking. Here goes. Okay. It was kind of nice not talking all the way through that, and I will go back to not talking for a while, but I just want to kind of point some things out. First of all, yeah, 0 and 1, whatever that is. Duh. But the idea that from -2 to 10, we can write -2 is less than or equal to x is less than or equal to 10. And this is what we mean, all the real numbers between. And then the comment I made over here, and I had to think about it after I wrote it for a second, if we're allowing or including, so less than or equal to, we'll use brackets. If we are using less than but not equal to, we'll use parentheses. And the interval of all real numbers less than 2 or greater than, there's no way you can have a number both less than and greater than. So we're going to say, you know what, it's either a number like this or it's a number like this. So we're actually blending together two intervals. We're blending together the interval from -infinity to 2 or the interval from 5 to infinity. Okay, look at the next page, page 29, and I'm going to go back to filling in some work. interjecting, notice that domain, you pick a spot on the graph and go to X. Label, domain, X. For range, you pick a spot on the graph and go to the Y-axis for range. And so these are three numbers where picked, 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 and went to the X-axis. I drew this wrong. Picked and went to the X-axis. Same thing for Y. Picked, went to the Y-axis. Picked, went to the Y-axis. Picked, went to the Y-axis. So really, everything between those two numbers is domain, and everything between those numbers is in the, those numbers is in the, I got that backwards, I'm sorry. Everything between these two numbers is range. Everything between these two numbers is domain. So to identify three values and not be part of the domain, just be outside or beyond the values of the function. Okay, I'm going to comment on this section before moving on. Literally, again, keeping considerate, that if I'm starting to see the function moves to the left, sorry, excuse me, I wrote a bunch and then didn't talk about it yet. The function moves to the left to -1 and then moves to the right to +1. This is the domain. If the function starts at the lowest at 0 and moves up to a height of 1, I mean, we are moving in this curve, but if you think about it like what's the level, 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 stop, there is no more, then the domain is green and the range is blue. Pause on that, think on that, turn the page, go on to page 30. So to consider these graphs, oops, sorry, not talking. Okay, so I'm going to leave the bottom comment alone, but I'm going to talk about this square root function right here. X exists provided that you are moving less than or equal to 4. And Y, the range, exists provided that you are greater than or equal to 0. For part B, the absolute value function, X is any real number, and this notation is what we call a bold face R. It's the symbol for real number. There are symbols for fractions and symbols for irrationals and symbols for complex and etc. So there are other things I can show them to you, but this is the symbol for a real number. It's basically a double downlined value, and then you swing the R around. But it's a symbol for real numbers. So X is an element of the real numbers, any real number possible. The Y value, the range, you check level, and so checking level up, 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 these arrows mean that the line's going to keep getting taller and taller and taller, but there is one spot where the line is lowest, and that's at -5. So Y for range is greater than or equal to -5. Over here, I just want to make sure I commented on the third graph. Notice the open circle at -5, and that's why I use the less than sign. The filled in circle at +5, that's why I get the equal to sign. Okay, I'm going to go on to page 31. Page 31, describe the domain of the function and write the domain in interval and inequality notation. Kind of challenging, don't really want to do it right now. Homework, haha. Okay, so we have example 6. Page 31, example 6. Provide a suitable domain and range to complete the definition of each function. This in inequality notation and then in interval notation. If you graph 2x plus 3, quick graph, quick sketch, 1, 2, 3, and 1, 2, 1, 1, 2, 1. It's a line. And because it's a line, the domain x is in the real numbers. That R looks kind of weird. Once again, it's kind of a bound, down, close it. Okay. The range, checking level, it goes up to infinity, it goes down to infinity. So the range is any f of x. That's also a real number. Kind of nice. Turn the page, go to page 32. Oh, sorry, that's the function that's not the function in either notation. Don't do it that way. I mean, you should know that, but don't do it that way. Inequality notation. Negative infinity is less than x is less than positive infinity. Interval notation. This is dumb, but we'll use it. Negative infinity is less than f of x is less than infinity, and this is still dumb, but it works. I think this actually is better. Okay, for this scenario. Turn the page, go to page 32. Aha, 2 to the x. What a great exponential function. What a great exponential function. Looks something like this. That's terribly drawn. Goes even steeper, not that part. There we go. That's the function 2 to the power of x. Its domain, all reals. It goes up, but it goes to the right. It goes down, but it goes to the left. Never stops in either direction. So the, wait. Yeah. That was a weird infinity sign. Okay, the range. The range never gets lower than 0, so it's all f of x greater than 0. Or we could write it like this. 0 to infinity. You know what? I buy that one. That one works really well. Never equal to. It has to be the strictly greater than or strictly a parenthesis, because this function, this 2 to the x function, never touches the x-axis. It never reaches 0. There's always a gap, even if it's like a tiny, tiny decimal value. All right, let's do 1. Does it continue to the next page? No, perfect. All right, so number 1, we have a set of, match the range, we have a set of dots. So range is -4, 0, 1, 5. That one. Again, range, check y values. Range, check y values. That y value, and 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 it keeps going that way. So that. So the range is all of those numbers. It's greater than or equal to -2. Okay. We want to talk range. So range is check that y value, check that y value, check that y value, check that y value, check that y value. Well, I'm checking y values, I'm going past the y-axis. But the point is the range is any of those numbers. So C. You thought it was going to be DAB, but it's not, it's C. Okay. Your closing section, describe a process to determine the domain of a function that has been graphed. I hope you understand that that's where this comes into play. That you think about, go to the function, look at like the x choices. To describe a method for determining the range of the function that's represented in a table, look at the y values. Look at y values. And with an expression, to determine the domain, looking at an expression, you probably want to graph it. You probably want to know about all types of functions. And that'll give you at least an idea when something typical comes up of how to respond for the domain. You should absolutely do the learning target success criteria check-in, and you should do the exit ticket because there's some really good repeated questions looking at the domain. This is also a question related to an SBA item. Oh, look, if you didn't think that practice was enough to help you get started, do the problem set for homework. Do the problem set. We'll do this one when I come back. Anyhow, there are your notes for the day. Have a good day. Hope you enjoy. See you on Friday.